So hi guys, welcome back to the channel. So guys, my name is Dheeraj. So in this video, we are going to solve a lead code question number 852. It is a medium level question on lead code. Name is peak index in a mountain array. So we will going to solve this question in a very simpler manner, and we will approach this problem with a 100% faster 100% faster success rate as compared to other solution available. So let's understand the question first of all. So the what question is saying that we have given an array and the array would be hold this property. The first property is it should be at least three element present in the array. And what this all these things what are these things are? This is basically they're saying that the array first gradually increasing and then decreasing. So we have to find the peak element of the array like this. Like here I've get the example here like this. It is first increasing and then decreasing. And one more thing, there is no element which is repeated. So there is no repeated element present in the array. Okay. So because if any element is repeated in the array, so it is not considered as mountain array. So what the example here is like here we have a 0 1 0 so it is minimum three element should be present in the array. And here you can see first it is 0 and then it's 1 then again 0. So what is increasing and then decreasing, so we have to find the highest and element in the array. So the highest element would be the peak element. So let's start with the problem. So I have taken an example here. As you can see, 0 2 3 4 5 2 1 0. So as you can see, it is first increasing till 5 and then decreasing from the 5. So here 5 is our peak element like this. So this is considered to a mountain array. And let's see the other example. Here you can see 0 2 3 3 and 5 2 1 0. So here it is increasing 0 to 2 and 2 to 3, but there is again a repeated element present which is 3. So it is on a linear form like this, and then again increasing and then decreasing. So this is not should be considered mountain array. Okay, hope you understand the problem. So what we are doing is we are simply applying the binary search method here. As you can see, I hope you know the binary search, how it's going to be how it's going to be applied on a normal searching array. When we have a sorted element, array, and we can simply find any element in the sorted array with using a binary search approach in a log n time. So we are doing the same approach here, but a little bit change here. What the change is, like in a sorted array, so what we have to do is like 1 2 3 4 and 5. I have taken an example of sorted array. In the sorted array, what we are doing is we are simply taking a start point and an end point, and we are also take a midpoint, start plus end, which is basically. So we are simply comparing our target element with this mid element, whether the target element is greater than mid or it is less than mid, or mid is greater than target. Okay, the same thing. So if this condition is follow, then we are simply doing is we are reducing our range. Suppose if we have to find the fourth element, index of fourth element, then we are simply comparing the mid element with this. If it is our mid is smaller than target, then we are simply ignoring this part of this portion of the array and searching the other portion of the part of the array. So we are doing the same thing here. And how we can do is, like take an example, 0 1 2 3 4 and then 3 2 1. So it the 4 should be the peak element because first increasing till 4 and then decreasing. So what we are doing is we are taking a start point as usual, and which is 0 zeroth index, and end point as usual, which is the array dot length -1 index, right? And then what we are doing is we are simply applying the loop which we are doing in binary search approach. What we are doing is while start is less than end, we are not doing the equal to end. We are not doing the start is less than or equal to end. The reason I will tell you later. uh, First go with this. So what we are doing is till this is true, we are taking a mid element. And then what we are doing is suppose we have taken the mid element start plus end divided by 2. Okay, and then we are comparing if array of mid greater than array of mid plus 1, and and array of mid is greater than mid minus 1. Why I'm doing this? Because as you can see, the peak element should be considered as peak if its right element is smaller than, and the left element is also smaller. So peak element, what do you mean by peak? The peak is basically the those element which has greater than is both element on the right hand side and the left hand side, right? It is obvious that if it increasing till the peak and then decreasing, so peak should be the highest value, na? It is obvious. So what my point is, in order to find the peak, any we have to search any element in the array which is larger than its right side of the element and the left side of the element. As simple as that. So what we are doing is here is, if we're taking a mid element and we are comparing it with mid plus 1, this we are comparing it with this, and mid minus 1, this. If this condition is fulfilled, then we will simply return mid. Else what we are doing is if array of mid is less than mid plus 1, if array of mid is less than mid plus 1, then what we are doing is we are ignoring this part. Suppose, like, if the element is like something like this, 1 2 3 4 and 5 and 2 1. So this is the peak. Suppose our mid is here. Suppose our mid is here. Suppose our mid is here, but this is the actual peak, right? And we are comparing, if this condition is not true, obviously this is not true here, then what we are doing is if array of mid is less than array of mid plus 1, if this mid is less than this, then what is mean is all the element here, the left side of the array is obviously in a sorted form, right? In a sorted form, whether increasing or decreasing. It's true. If the mid plus 1 element is greater than mid, if mid plus 1 element is greater than mid, that's mean all the elements present on the left side of the mid is obviously smaller than it. Sorted array, na? This is sorted array, na? So obviously this if this mid plus 1 is greater, then all the element to the left is obviously smaller than mid. So we are simply not gonna find our peak element here. Not gonna find our peak element here. So the peak element should be lie here. So this is the same approach in a binary search, simple binary search, like we are doing, but the only change is we are comparing it with mid plus 1 element. So if array of mid is less than array of mid plus 1, then we are simply is doing is start is equal to mid plus 1, right? And what is the other condition? If it is not smaller, it is greater. If array of mid is greater than mid plus 1, then what is that mean is, if our element is here, suppose our mid is here, if our mid is here, if this mid is not smaller than this, obviously this is greater, na? So we are in a decreasing part of the array. We are in a decreasing part of the array. Here we are increasing part of the array, here we are decreasing part of the array. I hope you are understanding what I want to convey you. If we are on a mid if our mid is here and we are comparing if mid is less than mid plus 1, no, it is not. Mid is not less than mid, it is greater. So this condition is become false, and we are moved to this condition. If mid is greater than mid plus 1, yes, mid is greater than mid plus 1, then it should be the possible candidate of a peak element. We cannot say that it is not a peak element. There is a possibility that it should be a peak element. Why? Suppose I remove this, and also this, and also this, and also this. Like what I want to say, 0 1 2 1, like this. If this is the mid and this condition, we hit on this condition, if mid is greater than mid plus 1, so there is a possibility that it should be a peak element. So that's why what we are doing is we are simply doing and is equal to mid, not mid minus 1. If we do mid minus 1, so then we will evacuate this 2, we will neglect this 2 from our answer. So we cannot do mid minus 1, we will do mid. So let's take a quick look what I want to say. If this is the mid, if this is the mid, then it is possible, it is 100% true that its right element should be less and the left element also a less from this. True. So I'm same what I want to convey is, let's make it a little simple. Let me take a look to the code directly so you can understand better how I've done this. So as you can see, so what I have done is simply taking a start point, right? Simply taking a start point here, taking a start point, taking an end point, okay, as and start is less than end, not equal to, because there is a moment when our start and end should be pointing to the same point. Because of this condition, this should be neglect, this should be neglect. If we do start less than equal to end, then we can simply you know time limit, we can hit a time limit exit, because our loop will not end, because there is a point we have to exit the loop. So in order to exit the loop, we have to write start is less than end. If we do start equal to end, less than equal to end, then the then loop will still run. If it pointing to the mid one element, it will still run, because we are not doing mid minus one. Okay, and then we can simply do is taking a mid element and then comparing it with its left element and then its right element, whether it is it is higher than both or not. If it is, then it turning the mid element. Else what we are doing is, if mid plus 1 is larger than it, then we are simply doing is start is equal to mid plus 1, because we cannot find our answer is in a left part of the array. This should be on the right part, right? And if it is else, what we are doing is marking our end to mid. Let's run this code. So as you can see, it is faster than 100% solution. And I hope you have liked my solution as well. So if you like it, please give us thumbs up and subscribe to my channel as well. We will see you in the next video. Take care. Bye.